All right, so as I was referencing before, you're looking at a heating curve here, and it's asking you which letter best represents the boiling point of substance X. I've said that your boiling point is the temperature at which something reaches before it goes through the phase change evaporation. So you have to understand, number one, what am I looking at in terms of my plateaus? What am I looking at in terms of my slopes? So we said that slopes are the areas of an increase in temperature. So you have a slope between A and B, you have a slope between points C and D, and you have a slope between points E and F. Between the slope here, you're looking at a solid. The slope here, you're looking at the state of matter that is liquid. And your slope here, you're looking at the state of matter that is a gas. And then that leaves you your areas of plateaus between points B and C and between points D and E. We've said in class that plateaus represent phase changes. So between B and C, you're looking at the phase change that is going from a solid to a liquid or melting. And between points D and E, you're looking at a phase change where you're going from a solid a liquid to a gas, and so you're looking at evaporation. So if you go back to the question, it says at which point best represents the boiling point. We said that boiling point is the temperature at which something begins to go through evaporation. Therefore, you should have said that option D was your best, or option D was what you were looking for here. Since they didn't give it to you initially in the study guide, I accepted E because you understood that during D through E, you're actually looking at evaporation, which includes a boiling point. But option D should have been the option given. It was not given. I made this note on many of your study guides that option D was actually the correct answer, and some of you even told me on your study guides that the correct answer wasn't listed because it was supposed to be D. So good for you guys. Now, if we look at question number 6, it says Roland's friend Andrew says the particles in substance X are not moving at all between points B and C. So between points B and C, Andrew is telling us that molecules are not moving. What you do notice is that between B and C, you're not seeing an increase in temperature, but you're still at a temperature. It's not like you're at 0 degrees. So what does this tell you? It tells you that, number one, molecules are always, 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 always in motion. At no point are molecules not moving. The only time that ever happens is at absolute 0, and it's not physically possible on Earth to get molecules to absolute 0. So never tell me that molecules are not moving. That's an effort issue question, and you'll receive Effort Academy if you get this question wrong on your upcoming assessment. It's unacceptable to tell me that molecules are not moving. I'm telling you right now, molecules are always moving. What you see here is you see that there is no increase in temperature. Between B and C, temperature is not changing. So you need to understand that temperature is a measure of kinetic energy, and kinetic energy is a measure of the speed at which molecules are moving. So between points B and C, you're seeing no increase in temperature, you're seeing no increase in kinetic energy, you're seeing no increase in the speed at which molecules are moving. So they're moving at the same speed throughout that time period. Throughout the time period between B and C, the molecules are not increasing their speed. They're still moving, they're just not increasing the speed at which they're moving. And this is because between points B and C, you're looking at a plateau, or you're looking at a region where you're going through a phase change. And during phase changes, we know that temperature doesn't increase because molecules are dealing with intermolecular forces that are changing. They're going from really strong intermolecular forces to somewhat moderately or weaker intermolecular forces in a liquid. So number 6, you should have told me that Andrew is wrong. He is wrong because molecules are always in motion, and it's just the fact that the speed of the molecules is not changing, not because they're not moving at all. All right, so now that brings us to question number 7. It says, what phase would substance X be in between points C and D? So I needed to let you guys know now that a phase and a phase change are not the same thing. Many of you told me that between points C and D, there's a phase change occurring. You know that that's wrong. You know that this represents a state of matter. Any slopes represent a state of matter. And some of you were just confused because you saw the word phase and you weren't closely reading. You didn't see phase change, you just saw phase. A phase is a solid, liquid, or a gas. A phase is a state of matter. A phase change is different. That's evaporation, that's melting, that's freezing, etc., etc. So it says, what phase would substance X be in between points C and D? If you go back up, between points C and D, you're looking at a liquid. And so I should have seen liquid for question number 7. Now, if we move down, we're on to question number 8. It says, what happens to kinetic energy? What happens to the kinetic energy of the particles between points A and B? This is a close reading issue with this question. Many of you wanted to describe to me the kinetic energy between points A and B. No, it says what happens to kinetic energy. So I needed to hear that kinetic energy between points A and B is changing. And because temperature is a measure of kinetic energy, the kinetic energy is increasing between points A and B. I didn't need to hear that it's somewhat low because it's in the form of a solid, etc., etc., etc. It's asking what's happening to it, and you needed to respond appropriately. Question number 9 says, what happens to the kinetic energy of the particles between points D and E? So, saying what's happening to the kinetic energy. So if we go back up at points D and E, what's happening? Well, kinetic energy is a measure of temperature. And because temperature is not changing, you need to do reference for me that kinetic energy is constant. I know this because the temperature is not changing and kinetic energy is a measure of temperature. And then you needed to tell me that why is it not changing? It's not changing because it's going through a phase change and it's focusing its energy into changing intermolecular forces instead of changing the speed at which molecules are moving. Now that brings us to question number 10. So question number 10. This was a somewhat challenging question for many students. Many of you wanted to talk to me about the speed at which gas molecules move, and that had nothing to do with it. This question was assessing your knowledge of the properties of gases. So it says, Alicia stood at one side of a room and sprayed her favorite perfume. A few seconds later, Michelle, who was standing 10 feet away on the other side of the room, could smell Alicia's perfume. Explain how the motion of gas molecules made it possible for Michelle to smell Alicia's perfume from across the room. So what you should have referenced in this question was you should have referenced number 1, gases take the shape of whatever container you put them into. So gases are going to take the shape of the room itself. The room is the container in this example, and they're going to move about and around the entire room until they have completely covered the entire room. You also should have referenced that gas molecules move extremely quickly. So she was able to smell them, number 1, because gas molecules take the shape of their container. The container in this example is the room. And number 2, you should have referenced that gas molecules move extremely quickly. And so that's what is also what made it possible for Michelle to smell the perfume. Those are the 2 things that you needed to include in this question. Many of you only referenced that gas molecules move extremely quickly. You did not reference that they take on the shape of their container, and the container in this example was the room. All right. Question number 11 was an experimental design question. It gave you an experiment, asked you to write a protocol, identify the variables, and then design a data table. The data table, same thing like I saw with the graph. There is a close reading issue, there is an effort issue. Students were not including titles for their table, nor were they including units. You were looking at here time, and many of you did not include a unit for time. I need to know, are you measuring the evaporation rate every minute, every second, every hour, every 5 hours? I needed a unit, and many of you did not include a unit in your data tables. So again, if I see this on your midterms, you'll stay for Effort Academy because that's a close reading issue, that's an effort issue. That brings us to the last question, which many of you had a lot of confusion when responding to. So it says, Daniela has drawn the diagram representing the movement in space between particles of water at 50 degrees Celsius and 90 degrees Celsius, but she forgot to label her diagrams with the correct temperature. Okay, so you have two models being given. You have diagram 3 and diagram 4, and you need to decide based off the question given. It says, which temperatures should Daniela label as diagram 4 using two pieces of evidence from the diagrams? So you're looking at diagram 4 here, and it's saying, should you label it as temperature 50 or temperature 90? And what I added here were some useful annotations for what I should be seeing you guys doing on your midterm. So diagram 3, number 1, what I'm looking at molecules, those are the blue circles, and then I'm looking at arrows. And what do these arrows represent? The arrows represent the movement and speed at which molecules are moving. So a short arrow tells me that they're not moving very much, they're not moving very quickly. When we look at diagram 4, we're looking at molecules again, but you're looking at longer arrows. The long arrows are going to tell me that molecules are moving a lot and they're moving very quickly. In addition to the movement of the molecules, I can also note the arrangement of the molecules themselves. So in diagram 3, the molecules are closely arranged, but not super close. And then in diagram 4, you notice that the molecules are less closely arranged or farther apart from each other compared to diagram 3. So I've already annotated two things that I'm seeing. I'm seeing the motion of molecules is different in both of these diagrams, and I'm seeing the spatial arrangement of the molecules is different in both of these diagrams. So now if we go back, it says, which temperature should she label diagram 4 as? Should she label it as 50 or 90? Well, you know that at higher temperatures, molecules move more quickly, they move farther apart, and so based off of that information, I would label diagram 4 as 90 degrees Celsius. What are my two pieces of evidence to support that? My two pieces of evidence are that the longer arrows show that there's faster movement between the molecules, which happens at higher temperature, and the molecules are farther apart from each other, which happens when molecules are at higher temperatures. Those are your two pieces of evidence, and that's how you should have been interpreting this model provided. I did not want to see what I was seeing where some students were giving me random temperatures to label diagram for us. No, that's a close reading issue. It asked, are you labeling it 50 or are you labeling it 90 degrees? There were no other options in between those two. It should have been one or the other, and you needed to make sure that you included two pieces of evidence, and many of you were not including two pieces of evidence. So that brings us to the end of your study guide. I do hope that you found this helpful, and if you have any remaining questions, please email me, reach out to me in school. I would be happy to take questions in regards to anything that you saw on the video, any questions that I did not address that you still have questions about. Please remember that you do have your revisions are due tomorrow, and I will be recollecting your study guides to give you point values for those. So I will see you tomorrow. Enjoy the remainder of your weekend.